Thank you for coming. It's fantastic that so many people are here tonight. And yeah, I will present this book to you tonight. Not only this book, but this book is the, let's say, hinging point of my talk tonight. I also brought a copy of the book, and this one is for you, so I leave this here. This is for your faculty, the copy. And so I will talk about the book, as I said. The book, that's also the making of the book. Why did we do it? How did we do it? It's the content in the book. What will you find in the book? And then my third point is to present some projects we did in Karlsruhe and which come like from the milieu of this book, because I think that's the nice thing we have in Karlsruhe at the moment, all around this building construction and building circular thing. There are people who teach, who publish, who research, and who build. And I want to give you an insight in that tonight. And I have to, no, we have a clock here, just that I don't talk too long. So when I say we published a book, who is we? We, that's two professorships at KIT. That's the professorship of Ludwig Wappner from Munich. You might know him. And it's the professorship of Dirk Hebel. He has the chair of sustainable construction in Karlsruhe. And obviously there's a lot of overlap in what the two chairs do, but each chair felt there's also a lack in, you know, we would need what the others can deliver. So we said, okay, let's join forces. And so we started, that must have been 2020, by doing a seminar which both chairs together did. And that was not a fantastic, great thing, but something which was very interesting. We realized that we also had some problems. We found a need to define certain things, and that's what we tried to do with the book. So we felt the need to define what is sustainable circular building. What is that? We felt that we need to, you know, provoke a little bit of a discussion, to kind of philosophy, to approach it also, you know, with regards to discussion before you start to design, to construct everything. We felt we need a stable manual, right? You have the Stahlbauatlas, you have the Holzbauatlas and all those things, but there is nothing you pick from the shelf if you ask yourself, you know, how do I approach sustainable circular building? And obviously, or of course, we always, as we are architects, we feel the need to give an impulse for future things. And as you noticed, I think I don't have to introduce why we think we need to build circular, right? I won't show you those slides of the blue planet and all the problems we're having at the moment. I presume you are aware of that, so I go right into the juicy bit. As also, there's a little bit of, there's not too much time to talk about that. Okay, that's what's in the book. So we have, check out this, does it? Yeah, so we have an introduction which gives a kind of definition of what we understand as circular construction. We have a part which provokes a certain discussion, and then we go into materials and how do you join materials and so forth, and we end with a manual of details which is structured according to 6 materials which we think are essential for circular construction. Okay, so this is the most complex slide I showed tonight, and it gets much easier. This is what we think, what we need to make possible, what we need to do. There are 2 circles. There's a technical circle and a biological circle, and we need to be able to keep all the materials we use, all the building elements, in one of the circles. The circles cannot be mixed. The circles are really 2 different things, and we need to keep our materials in those loops endlessly, right? So that means, as a next step, certain things. For example, downcycling is no good, right? Downcycling means reuse of materials, but on a lower level of quality, right? Something which was a stable wall before would, for example, be the screed under a street in the next step. That's downcycling. That's no good because you cannot do that endlessly. And obviously, it also involves that, you know, the longer something lasts, so less cycles are, the slow cycle is a good cycle. And what we also need to do, and that's where the title is derived from, is we need to separate things, right? If we want to reuse materials, then we need to separate them. And it's exactly the same what we do or try to do with, like, from our living, the garbage, right? If a house is at the end of its life, then if we have a pile of metal, a pile of wood, a pile of glass, then we are fine, then we can use that again. So this means Sortenrein Bauen, that we can separate them to keep them in the loop. And just to be clear about that, that doesn't mean we want to disassemble or like to only have materials. It also obviously applies to building elements, right? For example, a window or something. We don't have to destroy it to only keep the glass in the loop. If we are able to say, I reuse the whole window, right? And that's an image from the 1950s where they had this house which didn't work for some reasons, I didn't find out. So, but they could assemble and disassemble it, and it's a very nice example. So this is what we want to achieve. I think that's easy to understand, much more difficult to do. And for the discussion, those are just some pages from the books, some chapters to really also give you a little bit of an impulse for thinking. This one is about the matter of fact that we think this reuse is also a cultural and an aesthetic thing, right? If you look back in history, you will find, right, they reused, all those columns were reused, and that was not to save whatever. That was really a cultural thing, to express things, an aesthetic thing also. And buildings were not designed from scratch, but buildings, you know, this kind of famous buildings you all know, they are not like designed by one architect, but they are the result of a long process of building and adding and taking away and so forth. And just, you know, those points to make you all think, to make us think, or to make aware of the fact that we will have, or we do look at our cities in a new way, right? The city is an urban mind. The city is also not something only to add to, but also to take away materials and reuse them. We think we can learn a lot from vernacular architecture, from old architecture, from simple architecture. So really keep away the fingers from the romantic stuff, but really look at the details. They are nice. We can learn a lot from temporary buildings, right? If you take, for example, Crystal Palace, 19th century, here on the left-hand side, this building was designed to be disassembled and reassembled at another place, and that's really very interesting. And from those buildings, we can learn a lot as, you know, the disassembling, the joints, the joining things and being able to take them apart again. That's very important for this Sortenrein Bauen. And of course, to be able to contribute to the discussion, you need to be aware of what's going on right now, right? There are a lot of buildings, pavilions, and so forth, which are built not only in Venice at the Biennale, but around the world, and there is really interesting stuff going on, and you can learn a lot from that. So then the next step is to say we go closer to building. That is obviously you need to choose the right materials, right? Like very essential at the beginning is to say, with what do I want to build? And we have a catalog of materials in our book as well, and our philosophy to this. And that's really like, I'm standing here, so what I tell you is also my philosophy. Not everybody of the team has exactly the same philosophy, but I think there's a core, you know, which unites us. And so you have to separate a bit. Probably other people from the team would tell it in a different way, but I think the core is the same. So we also don't think too much like in good and bad, right? Like at the moment, like if you look at building in Germany, it's built in wood. Wood is good, concrete is bad, and this is something which we don't think is, you know, in the end it's true, but it's you know, you have to differentiate C8 concrete can be good as well. Also, if you look at a circular building, and like this, we discuss a lot of materials here in the book and help to understand them. And then when it comes to the building, we think you have to also look a little bit, what's going on, building strategies, let's say, and it's like we're very much interested in digital tools because we think they help a lot with circular building. And I'm really not going into detail, but it's obvious that if you want to reuse, there's a lot of logistics you have to save. There's a lot of things where you have unique parts you want to reuse. It's only one window is like that, other window is like that. How do you reuse? And digital tools will be able, or are right now already able, to help us a lot with that. And another thing is that obviously it's not always build new, use existing buildings, right? Use things which are already built, because taking them apart, that all costs energy. And by the way, we are also happy, we also, like in the book, we invited some other people, like not from KIT, to write, to give their point of view. And here we have Thomas Auer and Andreas Hild, and we're very happy that they did write something for our book. And and then we slowly come to the actual point of building, right? And that's now, the book is like made also for the context of building, but not also. We think also just for architects, people practicing. But we felt that it would be good to really build from scratch a little bit the logic of building, because you need to understand what you do, how do you assemble things, and that's why we said, okay, how are materials joined? And if I want to reuse something, you need to be able to understand, right? I put a column onto the floor. What does that mean? How do I put it there, and how can I take it away, and so forth? So we have a catalog of how do we join things, and the next step is layering, right? We need to understand, like in a wall or in a floor, what's going on there. It's like we need insulation, we need to make it windproof, it needs to be able to stand certain loads, and so forth and so forth. How do we do it? And the layering does allow us to, right, take things apart again, because obviously in recent building in Germany, the tendency is to glue everything together, right? Like nice thing, I mean, the word Wärmedämmverbundsystem, for example, says it all, right? You glue it all together, and that works well for a certain time, but then you're in a dead end, right? So that gluing things together, that's something we want to avoid, and that's not that easy, because there's those compound things ready from the shelf for whatever you need. And if you say, I want to develop something on my own, then it gets much more difficult. And as a first step, you just need to understand that model, and this is something we want to help here. Okay, and then we come to the detail catalog, as we call it. We always write something about the materials we use. So why is wood good, or why is wood not always good? Why can wood also have problems with circularity? And then we have those drawings, right? With every materials comes a handful or so details. We always have like 2 pages, right? Those two belong together. It's the same very simple house. Those are houses which are not existing, right? We kind of invented them. Like in the discussion, we said, oh, how can we do it? How can we make it more circular, more easy? They are relatively complex, the details. So a point of discussion is obviously also that simple building. We try to build simple, but that's in many cases not possible. So this is kind of the most simple we could imagine, but still it's more complex than we would like it to be. And so we have those drawings with, and I really like them. It's really a book where I think it's, even for me that I know the book very well, I like to just look at those, because I also like the graphics and stuff, and that's nice if you work with the THALK, right? They are very good with that, so I'm very happy with the result. And like this, we go through the materials. We have the bricks, and they are like, always realizing, because the brick itself is not the problem. The problem is the mortar between the brick. And like long time ago, until the Second World War, you could take the mortar away, right? After Second World War in Germany, they could reuse the bricks, and you can still now reuse the bricks of old walls, but the new mortar is more or less cement, and you cannot get that stuff off the stone, right? And that's the problem. And theoretically, you can build in a way where you can clean the stone from the mortar again to reuse it, but this do German building regulations at the moment not allow, right? So those are the things one needs to understand to then, as a next step, say, okay, what can I change? What can I do that we solve those problems? And our details, I won't go into depth. I think that's useless here to explain you those details. I just want to give you an impression. And of course, the details have the problem that you cannot like one-to-one take them and build them. You might get problems with building regulations and stuff. So this is just a combination of us where we think on the one hand, we try to stay close to reality, that we can say, okay, we can give this also to students and say, okay, this is the basis for your thinking. But on the other hand, we felt a certain need to leave certain rules behind, and say, okay, this might be how we can do it if regulations change a bit or whatever. Same with concrete. We have concrete in here, as we do think sometimes it is useful. Just think of prefab concrete. You can use those building elements again. So if you use them often enough or long enough, we think concrete can be a good thing to do. Steel is also interesting, because steel, like all metals, can very easily be kept in the technical circle. The problem is the coating, right? You need to paint it, to coat it somehow to protect the steel from corrosion, and getting those things off is really a problem. So how do you deal with that? And those are all the things one can learn when going from the book, or clay is a really nice material. However, you learn things, for example, right, clay is really a fantastic material, but the clay itself needs to be certified. And there are only little factories in Germany which provide certified clay, which means you have to transport the clay for a long distance, which means if you ask the experts in CO2, they might tell you that concrete is better than clay, because the concrete is produced like 20 kilometers away, whereas your clay is transported over 200 kilometers, although it's the same clay you have right next door, but there's no certificate for that, right? So those are things one needs to understand, I think, and this is not like, it doesn't change anything in the detail where the clay comes from, but that's reality of building in Germany and probably elsewhere. Right, so I already come to an end with the book, but really look at it. As I said, I leave this here, and we hope really that it also finds its way into teaching, into education. And and then a last word to who are we, because that's really the project got kind of bigger and bigger, right? In the beginning we were like from each chair 3 people, and in the beginning we were 6 people sitting together and saying, let's do that book. And then we have like the core team, the editors, which are from the chairs, and then we invited people to write, which are not all editors. And then we have a huge drafting team that was really also something which we underestimated in the beginning. So really we had students drafting for us. And so this book is really, I didn't count, but it's really many, many people involved in this book. And we're all very, very happy to have it in our hands now. Okay, and all the people involved in the book, as I said, are also built. And I want to show you some buildings, and kind of reality check, of course, also. And the first project I want to show you, that's a project we did at the chair of Ludwig Wapner, so building construction. We did a competition for students of our faculty. There's a camping yard close to Karlsruhe, and they wanted tiny houses to be able to let them to people. And they asked us whether we could make a proposal for those tiny houses on that camping site. And we did a competition. This team won. And then as the next step, we said, okay, let's build that then. And that was really, in the beginning, a bit naive. And we had Corona. So, yeah, this is how we started then, saying, okay, let's build that house with the students and yeah, but somehow we moved. We found partners. That's very, very important. So we have this Bauwerk Schwarzwald. That's, in the end of the day, the wood industry of the Black Forest, who said, okay, we support you. We have a school for carpenters in Freiburg who wanted to work together with us, and another school for building-related things like the ComZ. And they all said, okay, we join you guys, let's build that house. And that gave us the optimism to say, okay, let's build it. And so really a very small house. Here are the plans, very simple, 4 beds, and 4 people could live there for some nights, and section. So obviously the design of the students was not that detailed, but we took their design, and together with a team of students, not only the students who did the design, but also other students, we brought the detailing and everything, the design further. And yeah, it's just that little house. And I also think those drawings are very important, because you need to understand, like, structure-wise, what are you doing, how do you assemble it, how do you disassemble it, and if you understand things, you're almost there to solve things, to solve your problems. So yeah, very important to draw. And then we needed a lot of materials, because we realized that KIT could not support us with anything. It's mainly a problem of bureaucracy. It's really a nightmare. So, but all those guys helped us. And then we could really start to build. And also, right, this project would be worth speaking about for an hour only. I go to it rather quickly, just to show you, give you an idea. Building the wooden walls, right, this insulation comes from the sea. You find it at the beach. That's a company in Karlsruhe, Neptune Therm it's called. So it's really stuff you find at the beach. The really wood without glue sounds that simple, isn't that simple? And then just one detail I want to show you, how to join 2 beams, and we wanted to use little steel. So as you might know, obviously screws are a good thing, but if you screw parallel to the fiber of the wood, that doesn't work. The screw is just pulled out. So what do you do? We did those, those wooden nails, that's not the called, these are Dübel, which we just put perpendicular to the fiber into the wood, and then you can screw, and the result is perfect. And it's that easy, but you have to calculate that. You have to find the right screw. In the beginning, the screws just broke because they needed to be too long, and so forth. So it's very easy in a way, but very complicated to make it real. And only one example to show you what we were busy with. So construction, we used those shingles. That's also a very nice thing. Old traditional technology. Well, technology is maybe not the right word, but nobody of us ever used before. So we looked at that, and we find it's like very complicated on the one hand, but you can do it on your own on the other hand. If you follow certain rules, and you find out that most of those are come from a factory where they are like with a big saw, and that's not what you want, right? You want those which are broken, because then the fibers of the wood are still closed and the water wouldn't go into the material but down the roof. So all those things you need to find out. You need to check where do you find the material, and that's the result then. That's the house as we finished it last summer. And I think the result is really, really nice, but it was really a big, big effort. We really underestimated what it means to build that house. But we're all very happy. It got some prizes already, and the interior, and that's that simple building, right? Here, to build circular is kind of easy because you are the client. You make the rules. There, you don't have to give any guarantee, and so that's relatively easy. And still, it was complicated enough. And that's our little tiny house, and that's part of the team who built it. Okay, second project, only one slide. That's the Solar Decathlon. You might know that. This is big European competition, which was won by Dirk Hebel's team from KIT. So this is what they built, and they won it. Big thing, but this thing is published many, many times. If you want, have a look. It's just interesting for the context of the book, because those are all projects, this know-how is in the book, and the problems of those projects also in the book, and it goes back and forth. And then the last project I show is a project I did with my office. And it's also, I think it's also nice because, for example, right, a colleague who works at the chair of Dirk Hebel, and she contributed to the book, and she's also employed in my office. And Dirk Hebel is also officially paid by the client of this project to support our project. And this is that we say it's all one big milieu, and we help each other, and that makes that we can do some nice things, I hope. And that project is the result of an ideas competition I won in 2017 for redensification of Karlsruhe. So I said, okay, let's put houses, let's do flats on top of existing garages. And that was okay, you win, you get 500 euros, and nobody cares anymore. And then actually really somebody came to me and said, okay, we are interested in that. Please, they have my client, they have 13,500 living units, and they have a lot of garages, and they said, we want to try this. So for them, I did a lot of studies, and one of them we realized, that's that one. And the great point in the moment was when we decided to build it, then we got really great funding from the state of Baden-Württemberg, and they said, okay, we like this project, we need those kind of ideas. How can you make it more interesting, more innovative? And we said, okay, we do it circular. And they gave us extra money to being able to make it circular, and with this money we could also pay the chair of Dirk Hebel to support us. And yeah, that made it really, really interesting. So also here I very briefly, watching the time, go through the project. It's a post-war settlement, right, where we were able to build that. We built 3 of them, 1, 2, 3, 4 flats in each of them. And obviously it goes together with, how do you upgrade this post-war environment, give it a new identity, bring young people there. It's students live here since 1st of October. Yeah, and so it's in a way very simple, right? Left-hand side, you see the ground floor, that's garages. So it's still in use as garage by the people who used it before as a garage. So we just had to tell them to go out there for a certain time, and then we built the stuff on top of the garages, and then they could go inside it again. And right-hand side, you see the plans. So 3 very, very small apartments, and 1 bigger one, and all this is here by this Laubengang thing. You can enter the apartments, and zack, that's a section, also very simple. And And again, those drawings where I think draw them to understand it. The layering and the question of how can you do that circular and everything. And then I, again, just show some examples of how we did that. Right here you see, again, the assemblage of the walls and hemp insulation. So far it's easy, and obviously you need those planks, this scaffolding on top of it. And there come some questions with this scaffolding, like first, they fix it with this machine. What is in this machine? Because normally it's nails, and if you want to get nails out again to reuse the plank, that's very difficult. And the second question about this is this needs to be windproof, windtight. How do you do that? Because you don't want to use any plastic stuff to seal it. So we found two answers to those two questions. Like first is, this is how those planks look. They have this Schwalbenschwanzverbindung, however you call that in English, right? And that makes it to a certain point airproof. So you don't need any plastic foil or something to add. And the second thing are those guys, so you can shoot them into the wood as you would shoot a nail, right, with this orange machine, but you can screw them out, right? So it's because you can also screw all those planks, but that makes it much more expensive. That takes much more time. But if you find something to shoot in and screw out, which is existing on the market, you just have to find it, right? Then you've solved a lot of problems for circularity. So this is what we did. And another thing, this house can also be disassembled, brought to another place, and be reassembled there. This is also something we got money from the state for to make this possible. So one problem, and really I go into depth at certain points to show you there are hundreds of other points I could talk about, but just, right, so one problem is you prefab the walls. What do you do with the electricity if you take it apart again? And we found a system, where you can plug and take it away again. So if you want to move the house, you can simply unplug your electricity between the walls, transport your house to another place, and reassemble it. We did a lot of urban mining, so those floors, which are about 100 years old, were reused in our apartments. This is a estate from the client, and they said, okay, we want to try this. We want to try to learn that our buildings are an urban mine, so we did it, and it worked well, but it was also much more difficult than we expected. We reused old doors, so those handles also, little details like the letter boxes. Those are also old letter boxes which we, from a house which would be demolished soon, and we took those. And last slides then kind of, so here you see the construction, so it looks like normal timber building. Under us there are the garages, and for example, how do you deal with the bathrooms, right? Those are prefab bathrooms from a material which is not that well for circularity, but to do it well, like the only circular bathroom would be of stainless steel, and that costs like way too much money. So we used those, but we can take them out again, we can refab them. So in that, it works not perfect, but it works okay, I think. And this is how it looks like now. So as I said, 1st of October, people moved in. So those are still not the final photos. We've not finally evaluated what we actually did there, but that's the finished project. And I also think I like those because, in the end, we're still architects. I think it's also about nice space and things which look good and aesthetics, and this is why we do it. And circularity comes, at least for me, on top, kind of. So yeah, I like those spaces, those spatial conditions here, right? And the dialogue with the old buildings. and yeah, with the trees, which are fantastic. So it's really like living in a tree house a bit. Actually, really the old floors, right, 100 years old, you don't actually notice they are. This is also a 100-year-old door in our new house. This is the bathroom. The color was much discussed. I don't know whether it's really, I mean, well, yeah, but it's exciting. And again, our mining door and photo from the throne. And that's it from my side. Thanks.
We're going to ask a couple questions here.
Yeah.
So I'll leave this with you, and then I'll go on. We have time for a couple questions. Does anyone have anyone? Any questions?
Yeah. Titan zinc. So without, and that was actually when I did the first design, when I won the competition, that thing had a color, a really nice color I was really in love with. So then Dirk came and told me, forget the color, right? You cannot do that, that's okay. So yeah, this is why it's gray. I think it's okay, but it's titan zinc, and you can very well take it off, recycle it, and reuse it, yeah. Fernwärme, how is it heated is the question. And the answer is Fernwärme, what's it? So like the city of Karlsruhe has a big heating, which is for all the city like. And the nice thing about that is you see the existing buildings, right? And those buildings were insulated, so their heating is kind of too strong. So our building works as like with regards to heating and to electricity, which is also to the solar panels. Our building works like a satellite to the old buildings, right? Which is like conceptually, I think, very nice that we think that we said, right, there are technical over capacities, we use them, but in reality that was also a nightmare, as if you touch a piece of technology, then you have to bring it to the new, standards, and that costs a lot of money. Yeah.
Would it have been possible to build more than just one floor?
Yeah. But I would give it a try. I think it's possible, yeah. To build with more than one floor on top of that was the question.
Last question before we have to go. There was someone over here. No? Yes?
Yeah. I just wanted to ask, how much is it more expensive, like to build circular compared to the normal?
That's not a good question, but a lot of people ask me. I have to say I don't know, but one point is you cannot say there's building non-circular and there's building circular, and what's the difference in price? It's not black and white, right? So the question is, how circular is this? It's not 100% circular, but I don't want to escape your question. So I would say, like with the standard we tried to achieve here, probably 30% more expensive, maybe. I guess, yeah.
There's going to be more time for more questions after the three presentations. We're going to have a panel discussion, so people will have time to talk. Thank you.
Hi, it's actually the first time I speak in front of so many people. Our students' activities are with 30 to 50 people, so it's kind of impressive. I work at the ZHAW, it's the architectural school in Winterthur, Fachhochschule, and we do reuse for 6 years, I think. And we had a lot of publication. That's 3 of the most famous one, and those who can maybe help you also. We had the first one is about how can you build with the existing buildings, how can you densify, how can you not make a Totalersatz and continue to build. The second one I will show you a bit. It's about the Halle K118 from Baubüro in situ, maybe you know it. And we also do like a lot of exposition. What's also important is that we try to share all the things we do. We had a summer school for students from all Europe with a lot of people. Bolthauser, Jan de Wilde, I think some of them you know. And we also have some courses for people who make advanced studies. It's what you can do after bachelor or master while you are working. And a lot of this is also implemented in master and bachelor courses. We also try to help architects by competitions. This one was a winning project, actually. And we have several research topics currently. We have one on how to reuse concrete, just started, it's kind of new. We also have the topic of reuse steel, how to make this happen. But we also are interested in materials, so we have a Werkstückhalle, I don't know it in English, where we receive every month some new mock-ups from different firms. The last one we received was from Hortus, from Herzogedömmerung. So it's kind of cool to see all these materials and kind of can touch them and put it then in the students' projects. We also believe in game. We think that we can learn a lot, not only with PowerPoints, but with games. That's our latest game. It's about reuse, and it kind of you should learn like everything I'm telling you this evening and a bit more with this game. And we also have digital games. It's this one just started also. It's like a SimCity where you begin in the 1950 and then you have 1 year to make your city CO2 neutral. So why reuse? I think you've seen this. 37% of the global CO2 is from the construction, like from us architects. And the number that I find even worse is, it's in Switzerland, but I think it's the same in Germany. 82% of the waste is also from construction. And so I think it's really something that we have to do, and reuse is the most impactful way to do both, like CO2, or to lower the CO2, but also reduce the waste. When I did these interviews with these firms about their products and like the green program, I quickly realized that my sustainable and their sustainable was not on the same level. It was often greenwashing, and I tried to ask a bit questions also about reuse and could we implement it or not. And often they responded, yeah, no, we do reuse. We, for example, take our windows back, took the PVC and put it back into a new product, and that's not reuse. And that's why I'm trying to explain you quickly what's the difference. So the first steps, the raw materials, manufacturing, the installation, it's the same everywhere. Then the first step that you can do, the most effective one, is to preserve. So you keep everything in place, you will leave it where it is, you sometimes have to clean it or maybe repair it. Then you have reuse, there you have to dismantle, transport, sometimes repair, and you put it in another project. And recycling is more like a demolition. Then you have your several wastes a lot of it goes to the disposal, and the rest can go back in the loop. And what's interesting is that most of the CO2 is by the manufacturing and the raw material supply. So even if you recycle, it's not enough to reach our goals of 2050. With reuse, you're about 10% of CO2 from a new material. By recycling, it depends on what you recycle, but it's around 75–85%. And also, recycling looks like this on the demolition sites. So you kind of see how less is really recycled. And on the left side, you see the reuse of windows by Baubureau in situ, and you see how clean and how carefully they're doing it. I think Falk already spoke a bit about spolia. What I found interesting is that it wasn't even a question. It was, you have some, I don't know, some posts, and you need to build a wall, so you cut the post and you put some bricks. And this was made like everywhere, even the Colosseum. The Colosseum looks like this now, not because it was not well preserved. A lot of those stones were actually like for building the new part of the city. And it's also not only in the antiquity, and I really like this drawing, kind of explain that we're kind of lonely in the history, and that it should get better. I mean, I hope. Architecture versus climate, that's kind of the big debate right now. This is a very nice article. There were two redactors, one from Hochpartei and one from Werkbau und Wohnen. And they both wrote an article about the new headquarters of SRF. It's kind of on national TV. And one said it was a really great building, nice architecture, and the other one was a bit negative because of the side of the ecological side. And so it's kind of an architecture gossip. They were like kind of a fight and writing it back to each other. And so at the end, they made an interview with both of the redactor and one neutral person. And they kind of talked about this impact of climate into architecture. And one of the questions was, what do you miss with reuse? And the answer was, I miss the smooth or the contradictory. It always looks like bricolage, like tinkering. And bricolage is really like a word that comes in almost every article about reuse. And I'm from the French part, so I kind of knew the word, but I used it not with architecture, or maybe like at 4 in the morning, like finishing your model, and it was bricolage, but not for my facade. And so just here, it means it refers to the use of available resources to solve a problem rather than developing a specific solution to the problem. And it's kind of true, but it also sounds a bit negative, so I wasn't really sure, is it a good or a bad word? And then I found a PhD from Fanny Liglis. She took 4 or 5 years to do this PhD about how the word bricolage is used in architecture. And it's a really new word. It appeared in the 60s. And it was kind of, you have the industry, it was like super fast, super standardized. And next to it you have bricolage. It's like this slow process. Is also meant to be in the free time. It's also not an intellectual thing. So it was kind of this also like negative because not intellectual. And later it was often used with DIY. For example, here you have a project from Walter Siegel when they had like this crisis and nobody could afford homes anymore in England. It was not an architect who kind of drew some houses that you could assemble like IKEA furniture. And the latest I saw it was in an article about some people were not okay with the fact that they were demolishing a whole hill to make concrete out of it. And so in the article, they also were using bricolage as like how they lived. And so it's really, it's a bad word to associate with architecture. And that's the step 2 of the gossip. The same redactor who said the bricolage before, then had 2 years after, had an interview with Kerstin Müller from Baubüro in situ. And also, like, they talked about this bricolage and how they think it is. And I think it's a really nice answer from her. We are often accused that we use architecture as bricolage. I would like to defend myself and say, then do it in your own style. You can also make use invisible, present it in a different way that we do. One does not require the other. And I think that's true. But the problem is we have not so many examples. I mean, we have some, but we always look at the same, with the same aesthetic. And so I'm really looking forward to see how it will develop. Matthias asked me to present this project. The institute I'm working in did the book with Baubüro in situ. I was not involved in the project at all, but they briefed me. And it's a really interesting building. So it's in Winterthur. That's our school, and on the same street is the building. So it was kind of easy to get every day, have a look. There is like this 2 levels floor industry, and they put 3 levels on the top. And what I found very interesting is this word of tolerance, and that it's really the thing you need to have in views. For example, the walls. I mean, they didn't know how big the windows will be until almost the end. And so they had to have an idea how can they tell the constructor, like, hey, we don't know how big it will be. Please don't build it like now. And so they have like this prefabricated timber construction that they could like make super quickly. And in the middle it's some straw, so it's also kind of flexible if you have a bit more or a bit less. And also on the facade, they found these steel profile panels on the industry next to it. So they took them down, and then afterwards they realized they're not all with the same profile, because I think the north facade or the west facade was like once refurbished, and so they couldn't like slide it together how they wanted to, and so that's how this detail was made with like this several levels. And that's also something with tolerance. I mean, you never know how big or how small the components will be. So there is a bit of design challenge. I will like try to quickly explain you how it happened. So at the very beginning, they knew that they had those windows because they were just next to it, but they didn't have any facade. So it was like, okay, we have these windows, we have to use it, or we want to use it, but didn't really know how. Second, they found the steel structure. And this is kind of funny because the footprint of the building and the structure of the steel doesn't match up, because it's not a square, it's like a square with like this angle on a side. And so they had like to choose between, okay, we have to kind of adapt, we have to cut, which cost a lot of money, or we leave it like this, and then we have like this, I don't know how it's called, Austragung. And so that's why they have an Austragung, not because they wanted to, it wasn't planned, but it kind of happened. They also had planned a staircase inside the building, and they found one, which was like the good height, but couldn't deserve every levels. And so they kind of had to put it out, and now it's a big element on the facade, but also it wasn't meant to be here. On the same urban mine, I found also these granite panels. They were throwing away, and one of the Bauteiljager was super sad about this, and so he took it with him. He didn't know if they could use it anywhere. It was too heavy for the facade. And now they have a super fancy staircase outside with some granite panels. And also the doors where we used, here also you have this kind of flexible timber construction and the steel panels. And so it's kind of the drawing on the first day of the project and how it finished. So it's really, I mean, it's 2-3 level, but otherwise it's not kind of the same. There is also a lot of new things with logistic. It looks complicated, but I will go step by step. The first thing you have to do is search all the materials. What they do is that they are working with demolition firms or with Bauteilbörsen. One very famous in Belgium is Rotterdam. And so they kind of, over the years, have a lot of contact privately, and they kind of now know where they can go to find something. Then is the assessment. Once you find all the components, you have to make sure that it also fits your project, not only on the architecture way, but also on the static or maybe fireproof and stuff like this. And so for the style construction, I think they had like an afternoon to decide if they could take it or not. So you have to work with also an engineer that was like willing to do all the calculation in one afternoon or in 1 hour. So it all happened super fast, and they were calculating, I think, the worst case scenario, if it was really a bad still, if it works, and it worked, so they could do it. Then you have the documentation. Once you say you want it, you have really to measure it, everything like super precisely. And what they do and hope that nobody steals it is that they put like this kind of sticker, and yeah, it didn't work all the time, I think. And then what's kind of the difficult part, you have to go to the client and tell him, we don't have any project, we don't know if we can use it in the project. We kind of think we can, 90% maybe, but you have to buy it now. And that's kind of the big problem with reuse right now. And also you don't only have one company to do contract with it. You see like underneath, that's all the companies that were in contact and just to dismantle and reinstall a window. And then you have the dismantling. They also like only can take things that a human can dismantle. They don't have any fancy automatized machine or something. So it's really, here it's only the panels that you can take with the ladder that's going away. And at the end, the transport. And you also have the storage. I mean, I don't know anything about storage, but now it's the architect who has to also look into this. Here they have the garage, but often it's also made by professionals. And I mean, it's also a very big expense that you don't had until now. And at the end, if all the steps went well, you can reinstall it. And ZHAW could track all this component, which is pretty interesting. Like really from the beginning, where you took it until the end, where you put it back. And they also looked at the cost. The thing that costed the most is to reinstall it. I mean, manpower is not cheap. And it's kind of almost cheaper, but not every time. So that's also something interesting. You would think that everything must be more expensive because it's kind of new. And they also looked at the CO2 emission, and that's kind of interesting because the transport is the biggest CO2 problem. And I mean, it comes from Basel to Zurich, which is maybe a third of Switzerland, about 1.5 hour by by car or by yeah. And so here you see it's like it really makes sense on the CO2 level. You're really around this 10% I said before. And so the result is that they could like save 60% of the CO2 compared to a new building. In the 40%, there is some problems. There were some issues with the structure, so they had to pour concrete, and it's mostly also because of a fire norm or another norm that you have like to put something that's not ecological and maybe also not so easy to disassemble. So maybe we can do even better in a few years. And that's my master thesis. So I kind of knew all this story because it happened just next to it. And my concern a bit with this topic of reuse was the facade. How should the facade look? And must it be like really like this kind of, okay, I have a window, I put a window, and I have this, I put it like this. And I kind of looked at it and wanted to find if there was any process to make this easier also for architects. Like little number, 1 square meters of window is 2 to 3 times worse than 1 square meter of concrete, which is 20 centimeter thick. So it's really a big number because we all say no concrete anymore or as little as it could be. But next to it, we make skyscrapers with only windows, so maybe it's something to keep in mind. In Switzerland, when I did the research, there were like 4 reasons why people did reuse. There is Rudolf Olcati, it's the father of the Olcati that we kind of know. He had like this collection of pretty building components that he was saving his garage, and every time he had a new project, he was like kind of trying to implement them. There's in situ, which we know, and it's kind of this political statement trying to show everybody it's possible. There's also a project, I think it's in the Netherlands, where they had CO2 to reach, and they wanted concrete, and so they took reused windows, so it kind of, the CO2 number was not that bad. And the last, and it's the cost, and that only can happen when it's small projects. Here it's an architecture firm. They did the office all by themselves and looked online for every component. And I mean, the costs now are pretty more expensive than the new component because all the time that you need to research is like pretty expensive. I live in Zurich, in this neighborhood, and so I kind of started to look where I could find windows. Every red building on the plan is a building that will be demolished in the 3 next years. There will be more, that's the one I found. And so I was kind of shocked because, I mean, it's a quarter from the neighborhood will disappear. And for there, I choose like 4 projects or 4 Siedlungen, and I counted every window that could be found there, 4,000 almost. So it's a lot. I draw them all also to show you how much it is. Yeah, but there's one good thing. It's that with all the windows that I found, a lot of them had like this kind of similar size. And there's a Göner who was like a carpenter, And he wanted to do as much as money as possible by selling windows. And so he was thinking about solution, how to make more windows faster. And so for a year, he tried like to only sell one size of window to every client, and it worked. And so all the other Windows fabricants like tried to do the same. And so between the 1920 and 1960, you can find a lot of Windows catalog with a lot of standardized size. So it's really that window of 120 that you can open in the middle, who was like the most sold. And yeah, then I looked at every window and put it in the catalog that I found and kind of compared the sizes, the materials, also which years. In this fall project, there are five types of windows from several years. Some are new, some are super old, 1930. But even the newer one, who like had a Sanierung, have the same size. So it's really, you can take this standardized size and do something new with it. So it's not random anymore how big the window will be. So with all this research, I had like some hypotheses. So for example, the windows from the last 20 years, they're super easy to dismantle. So that's not a problem. You can like just cut everything that is glued, but you can take it out as an element super easily. There is a big problem with asbestos, with all the windows that are before 1990. But there is a possibility to only take like the openers from it, and so like you kind of don't have this problem anymore. And yeah, so then I looked at it a bit more in details with every window. I won't show you every of them. And I looked with the carpenter, how can we really like transform it to a window that would be as good as a new one. And also with pricing, because that's kind of the problem now. You don't want to pay more for something that's older. And that's the price with and without asbestos. That's why there is big differences. And it's also the price if the thing would be super organized, if it's would be produced like a new window, like super fast, super standardized. And so what was also important was the heating. So you don't want to heat more because you have bad windows. And so we calculated if you put two of the old windows together, how would it be? And you have to heat less with two old windows than the new one, because the new windows have some protection against the sun. So you cannot gain any sun energy in your house, which you can do with the older ones, with the solar protection, of course. And because it's an architecture thesis, there's also some architecture in it. So for me, window shouldn't be just a hole in the facade and you can open it and close it. And you have these super fancy references that we don't really have in Switzerland, and I don't think you have it in Germany. But it was kind of the basis to then create some new room with these windows. And so I took every room and I looked, I had like this wish list, what I want to do with it, and then took the windows I found to create those spaces. So that's the living room. You have the office, the kitchen with some shelves. What's also important is that you don't need to open every window, and that's the case right now. And that's also why you cannot keep those windows too long, because like this, all these metallic things get broken. And in the bathroom also you can look outside the window from your bathtub. and the bedroom. And winter, we really like to make it look like we can build it tomorrow. So I had to choose where we could build it, and there was like this competition from Lütjen Padawan and Caruso St. John. It's here. They will build it, I think, in a few months. They had like every ground floor already made, and I did like the facade for their project. I mean, they won't build it, but they have seen it. And so it looks kind of this. So you see like this kind of very strong 60 by 120. And what was kind of interesting is because all the windows are like kind of the same sizes, the sun protection also have like this sizes. So it was taken to put it on the facade, and you have like sometimes this, you can put it down and then you have the protection. Here you see like every room has its own kind of window. And yeah, here's the sun protection. And then I looked at what is new on my facade, what is reused, how's the difference with the prices and the CO2. So you see in green is everything that is reused, and where it is new, it's big differences by the price and also by the CO2. And one aspect that was super important also is that you could disassembly after it, and the tolerance to build it. So you see it's green, red, and blue, it's all the elements that can take this tolerance. And you can have windows that are 10 centimeter bigger on both sides, and it would still work because you have like some details that could adapt to those different sizes. It's like in the THALK 118, kind of the same principle. You would put the windows before you put it on the construction site, and at the end you would assembly the facade elements. What is also super important is, because it's a reuse window, you don't have any guarantee on it, or at least not now, and so you should be able to dismantle and put a new one pretty quickly if it doesn't work. And so that's kind of an idea how it could work without any scaffolder, would be super expensive. And then the costs, I mean, I have kind of an idea that it could be about the same price as the facade from the competition. But I mean, we haven't tried it, so maybe don't look too much at the prices. And last thing, I did all my semester with reused materials. I was thinking if I do like big theories about reuse, I cannot do some models with like super expensive and new products. And then I found out that in Germany you have, from the TU München, a competition for reuse model, that you can take a picture and send it. So maybe that's a thing for you. And yeah, that's it.
Just a few questions.
Oh, yeah.
We're going to have time for a couple questions, and then we're going to have a 10-minute break, and then we're going to have the final presentation. I will come to you with a microphone also, unless you want to yell. So, any questions, please?
Is this the mic?
Yep.
I have a question. It's a bit too loud, right? Okay, sorry. I'm not used to this, but I have a question about accessibility, especially talking about the windows. In the beginning of your presentation, you were mentioning that, especially in situ, they have managed to get these connections over a couple of years. So like what I ask myself, if I don't have the connection like this, how can I like get to this kind of project in a way that like how can I get these products? Is there any kind of database so far you know about, or will there be any kind of database maybe also in whole Europe to like share these kind of products? Is there something going on right now?
I mean, in Switzerland we are not like into Europe, so I don't know about Europe things. We are like kind of lonely in the middle there. But In Situ has now another firm that it's called Circular, and they're like kind of helping with this, so architects don't have to do it. Yeah, and so you don't have to search all these materials, and I don't remember the second part of your question. The database. I think there is no big database. You have this Bauteilbörse, but when you look online, yeah, there is not much. What I know is also that, like, in Switzerland, again, Zurich and Basel are now trying like to make more reuse, and so they are making competition with reuse, and they have their own books about which material you can use. It also makes more sense when the city was like making this competition already has some materials from other projects, and so it's kind of intern, and the circle is kind of way easier than if you have to ask 1,000 neighbors and they all want money, but yeah.
Hello? Okay. I can answer your question. Actually, there is a database in Germany. It's called Concula. They're involved in very big projects some of the times, where they help disassembly some buildings and catalog them, and they're growing actually. I think this year they got a huge storage facility, so yeah.
Nice. We don't have it.
Okay, so if everyone can be back here about 20 till 6, grab a drink also. There should be enough for everyone. Thank you very much. Michelle?
It's called Beyond and Before, Reimagining Materials' Second Life. I will elaborate what it means in a few moments. Before diving into the lecture, I would like to give a quick, brief context of the company, MVRDV. So MVRDV was founded by Winnie Maas, Jacob van Rijs, and Nathalie de Vries in 1993. So actually this year we are celebrating our 30th birthday. And now we have more than 300 staff global-wise from more than 30 nationalities. And we have our headquarters in Rotterdam, and we have an office in Berlin, office in Paris, office in Shanghai, and recently a new office in New York. We have more than 1,000 projects over 47 countries. And this is our home in Rotterdam. And maybe you heard our name through some famous early projects, the Villa Vipro in Hilversum, and this Dutch Expo 2000 in Hanover, and the Wotsoko in Amsterdam for the elderly building, residential, and the Silodam, and the Tianjin Library, and Su Sky Bridge. By the way, this is a reuse project. And the depot, which is for the Boymus Museum as a public archive for the art pieces, art collections of the museum. And of course the market hall in Rotterdam. together with many other projects we do globally in the world. And apart from the projects, we also publish a lot of books with our thoughts. And on the side of running the office, we also engage with academic. So this is the Y Factory, which is run at the faculty of TU Delft, which focuses on exploring future cities. And again, the Y Factory also published their research through a series of books about future cities. So a little bit of history of MVRDV. It's always been data-driven. It was the early works and early thoughts of the office pretty much focuses on data. For example, the book FarmX in 1998, from the name, it's like focusing on maximize the FAR. So it's talking about density. What is the extreme density you can imagine? As we know, Netherlands is one of the densest countries in the world. And here the KM3, it means from cubic meter to cubic kilometer, since the space we needed nowadays is much more challenging than the old days. And also the Meta-City Dataton, as an example, is a brutal visualization of a fictional city made completely with data. And there's also a video imagining the whole Netherlands is compressed into one cube with dimension of 3.5 kilometers. And we also develop visionary tools to bring these ideas down to the ground. For example, we have this, the vertical village, which focuses on how to maintain the identity of the individual buildings while keeping growing the density. So to do that, we developed a series of scripts which tries to analyze the situation of the build-up of the buildings. So here you can see all the layers from the massing to the circulation to the view to the sunlight. And here you can see a small demo of the software. Let's say we were using Grasshopper, develop this tool as a village maker. So first start with some circulation, and the blue cone is the view cone, and the orange one is for the sun. And then here you can show some evaluation of the spatial quality of different compositions of the buildings, and how do you locate the next layer on top of the existing ones, until finally you have a more or less reasonable composition of the houses. So based on this context, in 2017, we founded a small in-house computational expert group called MVRDV Next. Next stands for New Experimental Technologies. Back then, it's pretty much focusing on the computational design. So the first version of MVRDV Next was really a small team, 5 people, and focusing on computational and data-driven design. But recently, of course, sustainability becomes a very urgent topic. So we now also include the climate team to Next. And here you can see our friend Moritz. That's also why I'm here today, because we were working together at MVRDV Next when he was doing internship. So back to the computational part of MVRDV Next. These are our design scopes, ranging from design optioneering. So we develop certain script to help rapidly visualizing different options. And also for complex geometries, we develop scripts to rationalize them, to make them feasible for construction and later phase. And we also have performance evaluation, so it goes together with the design optioneering, because every time you have option, you have to evaluate how good is the option. And we have advanced geometries, like those geometries without computational tools are really hard to make. And we also have research and development. Here we are usually working together with some government, city halls, to visualize their impact, the impact of the policies on urban level, and propose some scenarios, some what ifs. And the last scope is new media, which personally I'm very interested. It's about using computational tool not only as a problem solver or as a design tool, but also as a way to retell a story in a more interesting or more inspirational way. So altogether, the scope of the computational team makes this cloud. So it has two dimensions. One dimension is the horizontal one, from visionary ones to towards more realization. And the other dimension is from small scale to large scale. And our scope is somewhere inside this matrix. But I'm not here today to only talk about the office, of course. We are here to talk about reuse. And as both Falk and Michelle mentioned, it's not a blue planet, but you get the idea. So this is an overlay of all kinds of graphs. And as a general tendency, you can see the consumption is growing, but the resources are going down. So there's an urgency of reuse. I think it's almost a cliche to say here. But what's probably the question is more about how to reuse. So here I want to show a bit of how we reuse in our practice. We try to reuse in every scale, from products to public buildings. So here you see an example of reuse the waste for products. This is carpet, and we are actually here recycling all the leftovers of other artists or designers. It was for the Milan Salone. So we were there together with all the other carpet designers, and all of them are using different kinds of threads. And for us, we were just wondering why not we collect the leftovers of all the other designers and make the carpet design into a big puzzle of, it's like a composition of different identities, but also it's a zero waste project. And also here is another example of the product of zero waste. We are here recycling the aluminum profiles to make them into a lamp design. And if we scale up a bit, we use recycled materials for facade designs for these luxury brands. Here we are looking at the Bulgari facade in Shanghai. Here we are recycling the beer bottles to make this kind of translucent jade-like material. And another recent project we just released a few days ago is a shop front for Tiffany in Singapore airport. And here we are reusing the trash in the sea, in the ocean, like this fish net or plastic mixed with some pigment. And we are here we are 3D printing with the recycled materials for this coral-like facade. And if we scale up one further, we repurpose for public buildings, of course, the famous Dutch Expo in 2000. It was really amazing in the picture, but in a few years, it's like this. So it's not in a good shape. And recently, we are working on a plan to reactivate the building and give it a new life. And this is another example in Shenzhen in China. This tower, high-rise, was built in the 80s, and it was pretty much empty for the last few decades. And we reused the structure and repurposed it and convert it into a hotel and a conventional center for mainly focusing on children and women. And it becomes a very popular new spot in Shenzhen nowadays. And also we reimagined some circular dreams, which is not yet very physically feasible to do. By the way, here is regarding the question was asked before, this is one example of the Concular as a database in Germany. So this is a project we were trying to do in Berlin, this Karstadt Hammerplatz. They were dismantling the facade and the building elements from the building, and Concular made a quite comprehensive catalog to document what materials are or building elements has been demounted and has the potential to be recycled and reused. But unfortunately, they only have pictures of them and numbers of them. So but they don't have the 3D model of the elements. So here is just like a very, very rough collage imagining how these recycled materials can have a new life in a new building. Which leads to this project, which is also the cover image. This is a recent project we finished in Amsterdam, the Matrix 1. It's an innovation center, and it's on the other side of this one. So it's very well documented. It has a very comprehensive BIM model, and the data is very accessible. So here is about using computational tool to have a visualization and to communicate to the general public. So this is just a few examples of the large reuse portfolio that MVRDV has been practicing. But the question here is also about when do we design during the material's lifespan. So if we have a line here, it's about the material's current status, like nowadays, like this chair, this floor. Like one dimension is to design beyond the material. So let's say, what do we do? If we can dismantle this floor, what do we do with the floor tomorrow? And another direction is we design before the material's current status. It's like you pre-think about the material is being used today, or you are considering how the material can be recycled at another place. So back to the scale of the reuse, we have product, we have facade, we have building. But like these two, this lamp profiles is a beyond. So it's like we are using the profiles to re-give it a new purpose. And also this facade is also, I have the waste in front of me, what can we do? But this is a before, because the building is running there, it's just newly built, and we are thinking about how to dismantle it and how the materials can be recycled at another place. And these are the three projects I will be highlighting in the coming time. Also because I'm from the computational part of MVRDV Next, and as the introduction of the event was indicating, I want to discuss with you guys what role can data-driven design or computational tools play in the practice of reuse. So first, let's have a look of the high profiles. The lamp, the product. So it's a beyond, it's a product. And I think the role of data-driven design here is mainly about optioneering. So this is a project with Delta Light, which is our client. They are a lamp company from Belgium. And they have all this very fancy light in the profiles, very clean. But we took a tour in their factory, and we saw they have a big collection of the waste. And these profiles are super expensive, and it's leftovers. They don't know what to do with them. So we come up with the idea of using these leftovers of these profiles to make something out of them, to make a new lamp. So we started with some random brainstorm, just to see what are the possibilities of rearranging, recomposing with the profile leftovers. Also testing the light effect when you have a light inside. How does it look like with different colors? And we also made some mock-ups, and also we are looking into the connectors, because the profiles, you can't have them loosely next to each other. They have to be connected, and you have to consider how the light can be installed, integrated in the composition. So this is the scripting part, and I developed a script which can look into the database of all the profiles, and then here it keeps monitoring the composition, like the profiles needed, the number of them, the type of them, and also other parameters like the rotation and the height, the shift. So it's a way of quickly visualizing all the possible compositions with what you have at hand. So in the end, we suddenly have a lot of mock-ups, like possible lamp compositions. And then we start to move on with the Delta Light. The company sent us a big box of all these leftover profiles. And then we start to make some handmade mock-ups. Like these are the connectors we were proposing, that you insert the profiles into this laser cut on both sides to stabilize them. And then in the end, design-wise, we went for a more geometrical, holistic shape, like a cube or like a tube. And here is about using the script again to quickly automatically generate different kinds of compositions. Like you can have different sizes and different diversity of the profiles. Sometimes you can have one lamp made of only one profile, like this, but sometimes you can make, like every profile can only be there once. So we made a collection of the design. Like this is the family photo of them. But in the end, we killed this one because these are 2 meters. And then it's not a leftover because 2 meters still you can install somewhere in the ceiling. So it goes against our idea of reuse. And then these are some mock-ups, like technical models from Delta Light. And this is the first, let's say, a bit serious mock-up, more than the in-house ones from us, the cube. And finally, last year, in 2022, it was launched in the Milano Salone. This was the showroom of Delta Light. And our partner Jakob was there in conversation with the Delta Light manager. And here I want to share with you a video of the make-off of the project.
MVRDV stands for surprising solutions to sometimes normal questions. We try to develop unique solutions for architecture, urban design, but also for landscapes, interiors, and even product design.
In the past, we did several projects with MVRDV, and we were very surprised how creative they were in the use of material, also in the shape of their buildings. And we were thinking, why not introduce their creativity in our product range?
The real spark was when we visited Delta Light and we saw the contrast between the front of house, the showroom, and the back of house, the factory. There were like all these raw materials stacked in beautiful rhythm. The concept of high profile is basically taking the aluminum profiles that we saw in the factory, taking the leftover pieces, and assembling them in a new way. And so a new product comes to life.
How they use the raw material to actually build a fixture. And you never see it, it's totally integrated in the architecture. And now it's becoming really a product on itself.
I profile is an exciting example of upcycling. I think you have a waste material that becomes something more than it used to be, and in this case, it also has a sort of luxury feel to it. By dipping it into a colorful jacket, so to say, giving it a color dip, this waste becomes actually de-wastified, so to say. That doesn't look like that.
And color is a very important aspect in many of the MVRDV designs. And this is also something we wanted to bring into the design of our profile. Also to add more color to the collection of Delta Light. So with parametric design, we were basically able to visualize many possibilities that maybe we could not think of just by ourselves. And basically are helped to think outside the box. So if you zoom into the details of this design, you could also see it as a fragment of a facade or a fragment of a master plan or a building fabric. It was not the intention here to create a fully functional luminaire, but to more focus on creating an atmosphere, to work with indirect light, and to work with the play of shadows that this object is creating. We have a lamp for the wall, we have a pendant lamp on the ceiling, we have a floor model. Basically anything can be built. What made me really happy that the collection in the end combines the quality of Delta Light with the distinctive style of MVRDV.
Yeah, that's how it looks like. Different versions. And we were quite lucky, like we got the Design Award of Best Lamp Design for 2022. And now it's finally fully developed as sellable products, and they have serious technical brochures. And if you look at the price, you know it's definitely an upcycling project. So the next project is about this Tiffany facade mentioned before in Singapore in the Changi airport. So it's also a beyond type, but it's a bit bigger, it's a facade. And the role of data-driven design here is about using scripting to achieve these complex geometries, first to model them in 3D software, but also to fabricate them. So in the beginning, the design team was exploring a lot of what is Tiffany, and it's about a lot of things about love, about their brand in New York, about diamonds, about nature, about craftsmanship, about dream, a 20th century icon. And also the question is how to bring all of this into the modern times. And one thing we can imagine is really about the materiality and also the iconography, transparency, context, audacity. So a lot of thoughts are going through in the design team's mind. And also this Tiffany blue is very a key identity of the brand. So in the end, they also, like all these different ideas, also have to land onto the local site in Singapore, in the Changi airport. So it's not a store on the street, but it's inside the airport in an interior environment. And in the end, the design team was proposing to have this coral pattern. And it also reminds me of the beautiful Tiffany blue color. Also reminds us of this unfortunate sea turtle, like stuck with this fish net and other ocean rubbishes. And we had come up with the idea with a few support of the suppliers that we could actually recycle these trashes and make them into this powder and mix with some pigments. Then eventually we can have quite rich, quite solid and reliable and also fireproof material which is 3D printable. So as the computational team, we were working together with the design team to develop this coral pattern on the facade. Also, not only on the 2D, but also we have to remap it back onto this 3D surface. And also we have to play with this gradient of the colors. This is the geometry, so basically it's like a Voronoi script with some attraction points. So you have smaller cells on the bottom and bigger cells on the top. And then this is a map of the color. So different letters stand for different color code, starting from the Tiffany blue to the navy blue. And in the middle, there are different proportions of the pigments to make this coral gradient. And also this is the picture of the 3D printing with the robots. It's printed by Actual. It's a 3D printing company based in Amsterdam. And when we're doing this print, they have to add these pigments during the printing process so that it's also having a gradient on the sectional part. So in the middle it's one color, on the edge it's another color. And in the end, it's just released a few days ago. So luckily I can present to all of you today here. So the facade is really beautiful, but it's actually made of recycled material, actually trash from the ocean. And the last project I want to talk about is actually the only before type we can have. It's the Matrix 1 Innovation Center in Amsterdam. And this building, the special part about this building is actually 90% of the building is demountable. And I think it's like when I was listening to Falk's presentation, it reminds me a lot of this project, because I think the circularity we have here is the first half. It's about the demountable part, but how it's going to be circular in the future after the material's current life, we still have to see. So the effort here from the data-driven design, the computational team, is mainly about visualize this demountability and tell the story to communicate to the general public, because otherwise the demountability also related to this question of the database. We actually uploaded everything, the whole BIM model as IFC type format onto the platform of Madaster. But in the end, it's like very dry report with numbers and the text is not very readable and accessible, let's say. And so this is the building. Before we released the constructed photos, this is the render. And so now if you go to the website to see the project, it doesn't look like this anymore. But the thing I want to highlight here is that it's so special about this building, the demountability, but when we try to communicate this feature, we only have a very poor diagram here. It says demountable structures, and another diagram here saying it's circular. So by that time, we are so proud of this, demountable feature. And actually one of my other ex-colleague here is also here, Joshua. Back then we were working together. We got, let's say, a commission from the design team and the climate team to, oh, sorry, something wrong with the timer, I guess. To elaborate this, oh, okay. So here you see we got a very comprehensive Revit model, and our task is to tell the story in a very visualized way. And we rebuild everything in Rhino, keeping their attributes. And we try different visual styles. Like we start to decompose the layers of the building and get all the Revit tags of the building. So here we can demount decompose the building into these different layers, ranging from the structure to the structure, the staff, the space plan, the services, the skin, and the structure. So this is sorted according to the lifespan of the components. So in the end, in the building, there are 121,000 elements. And here, our effort is to visualize in a very brutal way, rather than a very simple diagram of how many building elements are you looking at and how many of them are actually demountable and has the potential to be recycled in the future. So our effort here is to using the computational tool to visualize the mass amount of data and to emotionally touch the people to make them aware of the potential of reuse. So this is a movie in the end. We made a fictional movie where we demount the building layer by layer according to their lifespan. So you see, starting with the staff, and now we move to the space plan, which has a lifespan of 10 to 15 years. And on the left side, you see the catalog of them, how many pieces and what's the shape, what is the attributes of them, how many pieces are there. The ceilings, the structure cladding, and now moving to the services, which is the MEP, all the pipes, even the plugs, the solar panels. And now moving to the skin, which has a lifespan of 25 to 50 years. And with the time goes on, these building elements are demounted, and in reality they would be stored somewhere in the warehouse. But here is a visualization of being uploaded to a cloud of archive. It's a database where future people can have access and see in their building which part they can reuse. Yeah, this is on the opening, our partner France and associate Mick, they were using this video to explain to the public how the demountability as idea works here. And here is actually the opening. I was imagining there, if everyone would give them a wrench or something, they would really demount one piece of the building and take home. That would be really fun. So here is the overview of the projects I have been talking about, and I have some, let's say it's reflections instead of conclusions, a few thoughts. So first, from the sustainability point of view, designers like us should always bear reuse in mind and think about the full lifespan of materials, like the circle that Falk was mentioning, keep them inside the circle. But also, from the creative point of view, I don't know if you know the term defamiliarization. It's a technique, but this kind of reuse brings a sense of humor or some surprises to the design project. Because, for example, the high profile, usually it's used in the ceiling as a profile, but if you use in such a way, it's a bit surprising for people, and people would like to have it as a product because of this feature of design. And I also want to discuss this, what's the role of data-driven design here, the methods and the tool, how can they contribute to the circular design here? And with the examples I showed here, they can help us to explore quickly a lot of options which you couldn't do without, and also modeling and digital fabricate these complex geometries, and then visualize and tell the story in another way to make the reuse or sustainability stories more attractive to the general public and also to ourselves as designers, that actually reuse and sustainability can be sexy. And here is interesting because like I was collecting all these reuse projects from our office, and the majority of them are beyond, not so many as before. And it makes me wondering, is it because like beyond is more like an urgent question because we already create a lot of waste, we have to think about how to reuse them. But before is one step further, that you are pre-concerning a problem which is not there yet. But I think maybe with the time being, the reuse becoming a more and more important topic, maybe more before is needed. And in the end, welcome to get in touch if you like what we do. And since we have a few more minutes, actually I have a few bonus slides. Yeah, I was afraid it will take too much time, but also like today we have been quite serious with like Falk with this very comprehensive menu of circularity, and Michelle showing her study of and practice of how to reuse the windows. Here I try to, maybe it's a bit deviating, but in a broader term of reuse, we can take a break from the physical world, which relates to this project here. It's Art City. It's actually a virtual project, and it's a fiction. And again, the role of data-driven design here is about visualization and storytelling. So this is actually a project for art fair in Amsterdam. It's called PAN. Every year in November, they have this event, and every time they will invite artists or designer to design a campaign image and to promote their event. So last year, they invited MVRDV and the Y Factory to design the promotion for them. And the first inspiration of the art fair, like this is the venue, and the first inspiration is that it really feels like a city, because you have not only have these streets, these street furnitures, and people walking on in between the two facades with all these stands of different art dealers, but also the art pieces. They are from different art dealers. They are different types. There are paintings, classic paintings, modern paintings, sculpture, antiques, and all of a sudden they all come to this place and they start to talk to each other, to have a coincidence with each other. It really feels like city. So we were thinking, why not make a fictional city completely made of art, where we can forget about all the instrumental elements, like you have to have streets for cars, for bikes, you have to have infrastructure, but only immersive in arts. So in the end, this is the campaign image we designed for them. It's a composition of 3D objects, art pieces like antiques, furniture, and sculptures, and classic paintings, modern sculptures. And we put these silhouettes into the composition, make it into a city scene that you can feel like exploring in this art city. But we also, again, developed a small film for this. And we were discussing how to compose this fictional city, starting from sorting the art pieces with their different attributes, and then how these art pieces become a grid city, and then they start to morph into different holistic shapes where people can have a different experience there. So in a way, it's a practice of reuse the existing art pieces to create new kind of art. So this was the event, like with our campaign image. With the, like in the week, our image was everywhere in the city, in metro stations, bus stations, and with our movie there in the lobby. And it's quite funny that some of the art dealers, they found out that their painting was on the cover of the campaign image, and they even hold a small conference to discuss why the designer was using our, like this was the art dealer, why we were using her art to to make the cover of the campaign image. So in this way, we are composing the art dealers and artists together. By coincidence, they start to have some talks, have some networks because of our Art City composition. So to end today's talk, I would like to present this last film to you. Thank you. It's really the end this time.
We're going to be taking questions from the floor. I don't know, should we just yell them out? If you can talk maybe a bit louder. I have an initial kind of question. Michelle, you talked a lot about tolerance as both almost a design tool, like figuring out kind of what you have and then bringing that into the real world. And I'm wondering, both Falk, you and Yayun, you both kind of touched upon it also in your own work, whether it's, you know, the big the database-driven design, or how you were talking about the different availabilities of some of the materials and colors and things like that. And I'm just curious as to, maybe just to start off, how you two think first about the idea, or Michelle's concept of tolerance that she kind of brought up and discussed.
Yeah, it's an interesting question. I think I was thinking about this also during Michelle's lecture. Like I think maybe for me a better word would be the adaptivity, because the more tolerance you have, the more adaptivity or the flexibility you can have, because you can just loosely fit. It's not a specific fit that has to be like rocket science level precise. So in this way, I see it's a big advantage in the circular practice. And like regarding this, I actually have a question for, should I? Or maybe you answer first.
I mean, tolerances are very important, and whether you build circular or not, but that's really like an experience from the studio when working with students. Most don't realize what tolerances are before they go into an office and then realize the problems you have if you have zero tolerances. So I think they're really a big thing to keep in mind when you design. We had this kind of same problem as you had. We had those reused doors where we also had the same problem. We didn't know how big shall like the gap in the construction be so we can fit it inside. But I very much, I think your approach is very clever, right? And I think this probably works. You need tolerances, but just for the discussion here, I think also, you know, if tolerances get too big, you do end again in the bricolage, right? And that's a problem, because really like when you just do a normal building and you say, okay, I'm safe if I have big tolerances, you are safe, but the result will be very imprecise. So that just as a counterposition, right, be aware of tolerances, but be also careful. I think if they are too big, you have a problem as well.
Any questions from the crowd?
Maybe have an answer.
Oh, yeah, no,
Like
of course.
And I think tolerance is like the key, but I also think that in order not to get in this bricolage, you have to work with layers. And the more layers you have, the more things you can kind of hide behind. And so I think the last 10, 20 years, like all the facades were like super glatt. And maybe we have to go back in kind of this 60 to 80 type of facade or construction where there's real layers. And when you have layers, you have this tolerance, but it's also easier to disassemble because you can like screw some things up and you don't have to have these millimeter things where you finish by gluing it together so it kind of holds.
Oh, I took the wrong mic. I'm sorry. I'm gonna have to run back with this.
So I have a question about the Tiffany & Co. or Delta Light projects. Like those two were kind of prestige projects. And I was wondering how you, like if you put the outcome of the knowledge into new projects kind of, because I assume like getting ocean plastic out of the ocean and put it into a facade, there's a lot of outcome in this project. And do you have an idea how you would like to turn this into more widely affordable projects?
Sorry.
I have to take the advantage of distance to think about it. Well, it's a tough question. I think in a way, as designers, it's a bit like this small anecdote about my haircut. Like as designers, it's fine to reuse the material, but usually we don't reuse ideas, no? Like every time we want to do something different. So yes, it's true that all these projects, like there's accumulation of knowledge. It would be great if it can, in a way, like be reimagined or reused in some other projects. Like, for example, we also have this comprehensive knowledge of I didn't show it today, the glass house in Amsterdam. You know, this brick facade. It used to be for which brand? Now it's Hermes. It was for Chanel in the beginning. Like, we also developed very comprehensive knowledge with the glass making and how to glue them, how do they work with the bricks, and we had some expertise from TU Delft and also working with the Burano in Venice. Only they can make such glass. So there are a lot of technical knowledge here. But I think as MVRDV, we are more focusing on the design concept. And yeah, we would like to always explore these new things. I think the next Tiffany, it has to be something different. The reuse the idea or the technology is not our main priority, let's say. But I think the manufacturers and the suppliers, it can also help them, like when they have similar, different architects or designers asking for similar stuff, like they can be the ones to make use of the knowledge. Doesn't have to be the original designers, I think.
So sorry, but I have to do that. I would say designers, don't be afraid to reuse ideas. Because now we're coming to design philosophy, and he says, which is very Dutch, I think, don't reuse your design. The designer wants to move on, but I would really say, come on, designers, reuse ideas. If they are good, why not reuse them? And what you said, like, for example, the architecture of the 1960s, which is very structural. There are really interesting, ideas, design ideas, technical ideas in that. And I would say, let's reuse them. And if we decide to reuse ideas, we obviously always, we work with them so they change. So I really think with this whole circular thing, we shouldn't be afraid to reuse ideas. We should, just as we reuse materials, we should also reuse ideas. And of course, always refine them, elaborate them, and then also something new will involve, which should also satisfy this need, which I totally with you. We are designers to make something new, but that new stuff can also evolve from the reuse of ideas.
Yes, I think evolution is the key word.
Yeah.
Yes.
At the beginning, you were talking about the materials, like the different levels from concrete and wood. And would you recommend one material that is in every kind of section better than the others?
That goes to me then. No. I mean, there is obviously a reason why everyone wants to build with wood now, right? This is what society, what politics, what they all tell us to do. So I think wood is really a material which is, with regards to circular building, very powerful, but it is also a material which we haven't used well the last decades. So, this is also a thing which comes into play. But if you ask me as a designer, right, I would say, you know, it's like, who is your favorite friend? You know, you won't answer that question. You know, sometimes there's an advantage to work with wood, and sometimes there's an advantage to work with steel. And also, I think, looking back, you know, there has been a time where we all tried to build pure, in a sense that it was either you build with wood or you build with concrete. And what comes up is that we build more hybrid constructions, so that we say, okay, so there's nothing wrong if I have the core of my building is concrete and my floor slabs are steel, and you know, this kind of thing. So it gets more hybrid. But I would not say like there's the ultimate material. No.
I have one more question, maybe for you, Michelle, also about how we kind of have seen now three presentations on the same topic. And one thing that the first two presentations talked about was always reusing what we already have in that sense. But Yayun kind of brought up the idea of when working also with people who are still producing new things, do you have you discussed, or when you have been in contact with anyone in the manufacturing space, for example, that are looking into the further ability of their products that they're developing now, how are they going to reuse them later? Something that Yayun brought up with the graph of thinking beyond or before, and that's something that maybe now many things are looking to the future. But if we don't look at that now, how do you think that will affect the future in that sense when it comes to maybe products or the way that we design buildings?
Yeah, that's kind of hard part, because like I tried to ask them this, and a lot of them said, yeah, no, but we cannot do this because architects always want something else. So it was like, it's the fault of the architect, it's not us, we only produce what they ask us. And the other part is, I mean, for now, with capitalismus, if they produce something that could be reused after, they're kind of losing money, and they're kind of afraid maybe also of losing money. And so the one thing I could imagine is that you kind of rent those things. But do you want to rent windows for 20, 30 years and then have to give it back because you don't know what happened? And so it's kind of difficult, but I also think that now they're trying to get into it, like slowly. But it's still on the research field. They're giving some money so we can test some things, but there is like not much concrete, like really now.
Final question.
I think one big topic, which is probably for all of you, and Falk already touched upon this, is scale of the projects. You said that already in your kind of small buildings, it was so much more effort than you were expecting. So I just wanted to ask very openly, what are your thoughts about upscaling the ideas, the techniques that you already kind of developed?
Well, I personally would very much like to upscale, and in the end we will need to upscale. I mean, that's a general observation on all those circular buildings. They are still rather small. So to change something with them, we need to upscale. And like I personally would like to upscale, you know, because somehow bigger projects are seductive, let's say. But the main problem is simply you need to find clients for that. And I think that's a reality check which is still ongoing, right? Because, right, the Tiffany guys, I mean, what really is circular, this is I mean, it's a huge company and they go into that, but it's a small item, like with relation to what is happening, you know, in the bigger picture. So we need to upscale, but that's really difficult. Yeah, that's really difficult. And the main point is, I think, to find clients. That's what I personally at the moment see as the issue, to find somebody who does it. You know, it's one thing to do nice stuff at the university and, you know, it's nice and small and looks good and so forth. But then when it's getting bigger, it's getting more serious and more money involved, and that makes it very, very difficult.
I think in the general level, I don't know if I can summarize today's three speakers like this, but I have the feeling like to touch upon the general topic of reuse. I think the three of us are getting closer to the topic from our aspect to have whole image. I think, Falk, you start with the very solid starting point, like the menu, and also your practice of the projects is a starting point of the circularity. Like I said, it's a demountable part. Like the ambition there is to have a small house or a project which can be demountable, but it's not demounted yet. So I think the circle is not complete yet. It's the starting point, and we have to see with the time being. I don't know if you have any plan of that, to keep tracking of your projects, like whether and how they can have a second life somewhere else. And I think, Michelle, in your lecture, you are a practicer of this reuse already, because you are choosing collecting the windows and already try to apply, like in your thesis project, already trying to apply to buildings. Also, it's the K118 project. And I think my part is, I think the most interesting part for the reuse topic is about the communication, because I think it's very important, also very difficult to communicate the importance and potential of reuse to designers, also to the general public, to tell them it can be a very interesting topic. And I think from these three aspects, together we are getting more and more close to this reuse topic. I don't know if it's a good summary of today's lecture. What do you think?
I mean, yeah, but I also think in Switzerland, in situ did like this super great job, like really communicating and showing everybody how it can work. And so now cities are kind of open to do it also, and private person also comes to the lectures sometimes, trying to see what this is. And one of the big problem, I think, it's also like this database. I mean, yeah, so you have picture and you have numbers, but if you cannot tell your client, hey, we could use this, this, and this, how you make it with a new project, it's kind of difficult to tell them, yeah, pay for something that you don't even know what you will have. And so I think that database are also a bit of the key. And I think that's starting now, and it will be getting bigger and better in the few next years. And so then it will be easier to build something big. I mean, what you did with your huge database, I mean, you can build another building of the same scale or two little ones, which is like 10 times bigger than your small pavilion, and it's because you have the information given.
So, okay, if this is like the conclusions, then my personal one, which really makes me think a lot, that's actually the bricolage, and I was very happy you really, put a big emphasis on the question of the bricolage, and we also discussed it a lot and at KIT. And my personal opinion is, right, we have at the moment this thing with the circularity. And if you look back to the 1920s, they had also something new, that was the concrete. So that they didn't really know what to do. Or in the 1890s, they had something new, and that was the steel. And in the beginning, it was all the bricolage. If you look at old stations, they are a bricolage in the sense you have a steel construction and a stone building, and they don't go together. This is classical bricolage that doesn't go together very well. But then after a time, things get sorted out and you get rid of this bricolage problem, and then it's only a problem of style. And my personal hope and opinion is that we will soon not have to talk about this bricolage issue anymore if we take this on a different level, that we can design. And of course, I don't have a clue where that goes, how we do that, but I think we will do it, and then I think we don't have to discuss the bricolage anymore. But I totally agree, and I'm very happy that you pointed out this thing, because at the moment it is a kind of, I think it's a kind of problem. Others say it's the specific style, and I think it will change, and that's cool. And that's what we have to work on.
Thank you very much for everyone coming. Thank you for spending your Friday evening, or at least the beginning of it, here. And just one more round of applause for our wonderful presenters.